Over 2,000 years ago, there was an amazing discovery about triangles. When a triangle has a right angle and squares are made on each of the three sides, then the biggest square has the exact same area as the other two squares put together. It is called Pythagorean Theorem or Pythagorean Theorem. And can be written in one short equation: a squared plus b squared equals c squared. In this lesson, you will be learning everything about the Pythagorean Theorem. Pythagorean Theorem is a formula used to solve a right triangle. Right triangles are triangles with a 90-degree angle. C is the longest side of the triangle, called the hypotenuse. It is found at the opposite side of the right angle, while A and B are the other two sides. In a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Now how about we try it and let's see if it works. Let's have this example. You are given this triangle and it has a 90-degree angle in it. Therefore, this triangle is a right triangle. The measure of the two sides are 3 and 4, while the hypotenuse is 5. Let us now check if the square of the hypotenuse is really equal to the sum of the squares of the other two sides. You have to remember that A and B are representations for the sides, so they are 3 and 4, while the hypotenuse is equal to 5, and that is your C. Next, we shall now substitute them in the Pythagorean theorem, which is a squared plus b squared equals c squared. Since our a is equal to 3, so that's gonna be 3 squared, plus the b is 4, so it's 4 squared, equals the c, which is 5, so that's gonna be 5 squared. 3 squared is equal to 9, 4 squared will become 16, and 5 squared is 25. Now we add 9 and 16, that's gonna be 25, equals to 25. So it's right, the square of the hypotenuse is indeed equal to the square of the sum of the other two sides. Okay, now that we know it works, how do we use it? This is actually very useful if we know the lengths of the two sides of a right-angled triangle. We can find the length of the third side. But remember, it only works on the right-angled triangles. To know what I mean, let's try this one out. To use it, we usually write it down as an equation, and then we use algebra to find any missing value, just like this example. Now let's solve the missing side of this triangle. The two sides here are 5 and 12, while the hypotenuse is unknown, so we only label it for now as C. Let us start by knowing our A and B, and they are the sides 5 and 12, while C remains unknown. Now it's time to use the Pythagorean theorem. A squared plus b squared equals c squared. Now we put in what we know. A is 5, so that's going to be 5 squared, plus b is 12, so we write 12 squared equals c is unknown, so we just write c squared. Then we calculate the squares. 5 squared is 25 plus 12 squared, which is 144, equals c squared. Next, we add 25 and 144. Their sum is 169. Copy equals c squared. Now to remove the squared, we must get the square root of both sides. Therefore, c is equal to 13. So the length of the hypotenuse is equal to 13. To master this lesson, let's try another one. In our previous example, the missing is the length of the hypotenuse. Now what about if this time the missing is the length of one of the other two sides? In this given triangle, one side is 9, the other is missing, so it's only B, and the hypotenuse is 15. So our A here is 9, our B is unknown, and our C is 15. Then write the Pythagorean theorem. A squared plus B squared equals C squared. Next, we substitute. That's going to be 9 squared plus B squared equals 15 squared. Calculate the squares. 9 squared is 81 plus B squared equals 15 squared is 225. We have to get rid of 81 by transposing it on the other side. And that will be possible if we take 81 from both sides. Now what remains on the left is B squared, and 225 minus 81 is 144. Get the square root of both sides, so B is equal to 12. Now you might be wondering, why aren't we writing the positive and the negative 12? This is for the reason that we are solving for the length of a triangle. And when we say length, there is no such thing as a negative length. So we get rid of it. We only consider the positive answers. How about this next problem that we have? What is the diagonal distance across a square of size 1? Let us start with our illustration. Let's assume that this square has sides equal to 1. Then the diagonal distance can be found from this point to that point. And as you can see, we were able to make a right triangle. Therefore, we may use the Pythagorean Theorem. Starting with A equals to 1, B equals to 1, and the C is missing. Then we substitute the values, so we will get 1 squared plus 1 squared equals C squared. Then we calculate the squares. That's going to be 1 plus 1 equals C squared. 1 plus 1 is 2, and get the square root of both sides, so square root of 2 is equal to 1.42. So the diagonal distance is approximately 1.42. You should take note that the Pythagorean theorem works the other way around too. When the three sides of a triangle make A squared plus B squared equals C squared, then the triangle is right angle, just like what we did in our first example. You can do that to check if the triangle has a right angle. Did you know that you can also prove the Pythagorean theorem yourself? Now get a paper. You may use a colored one if you want to be more creative, pen and scissors. Then use the following steps. First, you have to draw a right angled triangle on the paper, leaving plenty of space. Next, draw a square along the hypotenuse, which is the longest side. Then, draw the same sized square on the other side of the hypotenuse. Then draw lines like this. Make sure to follow the steps correctly. Now you may cut out the shapes. And finally, you may now arrange them so that you can prove that the big square has the same area as the two squares on the other sides. Now, if you're wondering how to do this, then you may go back to the first video I showed you a while ago to get an idea on how to do this, because it's somewhat like that. I know you can do this. Now here are some interesting facts that you must know before we end. Pythagorean theorem was named after the Greek mathematician Pythagoras. Yep, this is him. Did you also know that there are hundreds of proofs for this theorem? Even James Garfield, the 20th President of the United States, had a proof. This is President James Garfield. And last but not least, everyone knows Pythagorean Theorem, but not who discovered it 1,000 years before. So as you see, these are only few of the numerous examples, problems, solutions, uses, applications, and facts about such a very important theorem. So I'll just leave the rest for you to explore. But I hope this video helps. See you till our next lesson. Stay safe.